Hello eye tracking community, my name is Michael, and in this video we will talk about how to select sections in your data based on a given data range. Everyone who is conducting user experiments with eye tracking knows this challenge. You're recording the eye tracking data together with some biometric data, together with some data from a driving simulator, with logging files, with some additional data streams. But during the analysis, you want to focus on specific sections. So for example, where the biometric sensors shows a specific behavior. Usually this means you have to write some scripts, you have to load the data into a spreadsheet software, you have to insert some columns, some formulas. This is a source for error, costs a lot of time and does not make fun. In this video, I will show you how you can select data in an easier and not so frustrating way. In this tutorial, I will show you 3 examples. The first one is eye tracking with biometric data. The second one is a desktop eye tracking experiment. And the third one is a car experiment. So let's have a look into the first use case. On the screen, we can see an eye tracking experiment where 3 participants were walking around in a room and have performed some given tasks. On the right side, we can see the biometric data. This data has been normalized, and I will show you in another video how easy it is in Blickshift Analytics to normalize data streams. And now I want to focus on a specific range of the biometric signals and want to focus my analysis only on these sections. And this goes like that. I go to the original data node, so to normalize data here on the left side, and I choose value search from the menu. Then I'm saying add row, and then here I choose the column GSR normalized. And since I want to select a specific range between 2 values, I'm saying GSR normalized should be greater than 0.6, add row, and GSR normalized should be smaller than 0.9. So let's go to the visualizations. And here I can see now the sections which belong to this search query, so to this range. So they are highlighted in blue. So we can see at one glance that this first participant here had this value shown this value range more in the beginning, where the second one is more or less over the whole experience in the whole experiment in this range, and the last participant reached this range in the second part of the experiment. Now I want to focus my analysis on this range of data, and that is simple. I do a right click somewhere on this blue area, on this blue section, same value search, and then I can choose from the menu all the powerful tools in our software, but now they are working only on this data section. Also, I can visualize, for example, only these sections in special visualizations. And by doing that, you can nicely see how the software first gives you an overview over the whole experiment, supports you in filtering with respect to different aspects, and then finally to focus on details in the data. So let's have a look on the desktop eye tracking experiment and what value search can do there for us. First, let's have a look at the experiment. And you can find this experiment in the first tutorials in this channel as well. So 9 participants have performed a reading task with visualizations. And when we look at the aggregated scan path, what we can see is that we have some eye movements on the top and some eye movements here at the bottom. And now I want to focus the analysis on the eye movements on the top of the stimulus, so on the top area. And this works like that. I choose here from the original data source, visual elements, the value search again. And now I can say add row, and I'm interested now in fixations with an Y value, which is smaller than, let's say, 300. So that's some middle of the screen. And when I'm visualizing now only this data, I can see that now the software only visualizes fixations with Y values smaller than 300. So the upper half of the visualization. So I go here with the right click, and then I can use all the tools in our software again, but now only for the fixations on the upper part of the visualization. Or I can visualize only this data with the visualizations in our software. Let's have a look on an automotive eye tracking experiment in the last example of this tutorial. So here we can see a driver driving through a city, and we can also see the profile, the velocity profile. And now I want to focus my analysis on a specific range of the velocity. And this works again like that. I'm choosing the value search, and then I'm saying value search greater, let's say 20 kilometers per hour. And now I can go to the line graph again, and here I can see all the sections where this participant has driven faster than 20 kilometers per hour. I can also visualize that for the others as well. And now I want to focus my analysis on that. And perhaps I show you another way how you can continue your analysis only on this section. You can also click here on the value search in the bottom in the Workflow Explorer and say right click visualizations, for example. And now I want to analyze the eye movements in these different during these different sections in a bit more detail and visualize them with a parallel scan path and check them all. So all the participants. And here I can see now the different sections, but only the sections where this driver has driven faster than 20 kilometers per hour. You can nicely see here the brakes in the data, so that's where the driver has driven slower. And you can also see the brakes and the time axis here, that they are not constantly with the same distance because you have the brakes in the data in between. And only this little component here gives you a very powerful tool. You don't have to write any lines of code to do a search for specific values. You can just do it here in a same kind like what you see is what you get. Thank you very much for watching this video. If you liked the video, please press the like button, share it with your community, and subscribe to our channel. And I'm looking forward to see you in the next video.